عملكم ورسوله المؤمن. صدق الله العظيم. في هذه المناسبة طبعا أبدأ الترحيب بالأستاذ الدكتور عبد المنعم بنا رئيس مركز البحوث الزراعية، ونيابة عن معالي الأستاذ الدكتور علي المركز وزير الزراعة والاستصلاح الأراضي. في نفس الوقت برضه بنرحب بالسادة الضيوف من مندوب الشركات الذين يعني استجابوا للدعوة النهارده، كما ارحب بالسادة الزملاء الباحثين في معهد بحوث القطن، واخص بالذكر برضه الزملاء قسم الرتب، احييهم على المجهود اللي هم بذلوه في الافتاح. نبدأ بكلمة السيد الأستاذ الدكتور عبد المنعم بنا رئيس مركز البحوث الزراعية، فليتفضل سيدي.
بسم الله الرحمن الرحيم. أولا بس تحيات مع الوزير الأستاذ الدكتور علي المركز، وهو كان يعني يتمنى الحضور ولكن بعض الالتزامات الأخرى. لو هنتكلم على موضوع النهارده افتتاح المركز التميز العلمي لتحديث ورفع وكفاءة نظام فرز القطن العتيق اليدوي المتبع حاليا في مصر. وطبعا انشاء المركز العلمي ده منحة طبعا من أكاديمية البحث العلمي، وطبعا احنا في تعاون كثير مع هذه مركز البحوث الزراعية وأكاديمية البحث العلمي. والهدف الرئيسي معروف ان كان نظام فرز القطن المتبع في مصر هو نظام قديم جدا يرجع لحوالي قرن من الزمان. هو الامر الذي استدعى حتميه مراجعه وتوضيح هذا النظام واعاده تصميمه وتطوير نظام جديد لفرز القطن المصري، والمنهج الذي يجب ان يتبع في هذا الصدد وهو استخدام الأجهزة الحديثة التي تستخدم في تقدير صفات جودة القطن. طبعا هذا الجهاز في المرحلة دي مهم جدا، ويمكن الإخوة العاملين في معهد بحوث القطن عارفين بعض المشاكل التي تجد على الساحة حاليا في موضوع القطن وموضوع الخلط اللي موجود. وأعتقد إن الوزارة تم تشكيل لجنة لمراجعة هذا الموضوع، وأعتقد إحنا حاليا واخدين اجراءات في هذا الموضوع. وبالتالي كان هناك تحديد واقعي ودقيق للقيمه الغزليه للفعليه للقطن، والتي بناء عليها يتم تحديد سعر عادل للقطن في المعاملات التجاريه في سوق القطن. وهذا المفهوم الحديث لفرز وتسويق القطن اصبح سائد في معظم دول العالم المنتجه والمصنعه للقطن، وهو المفهوم اعتقد يمكن هذا المفهوم بدا في الولايات المتحدة الأمريكية في الثمانينات. والهدف الرئيسي لإنشاء هذا المركز التميز العلمي هو التحديث والارتقاء بوسائل البحث، وذلك من خلال تزويد هذا المركز بأحدث أجهزة الاختبار، وهي بالتحديد أجهزة CCCP5 التي تستخدم لقياس صفات جودة تيلة القطن والعوامل المحددة بجودة القطن بغرض استخدام هذه البيانات في مجالات بحوث جودة القطن وفرز وتسويق القطن. بالإضافة إلى هيتيح الفرصة للباحثين في مجال بحوث القطن للاستفادة من هذا الموضوع، وايضا برضو مع الجامعات والمراكز البحثيه الاخرى في هذا المجال، وايضا المعنيين بتجاره القطن محليا وخارجيا هي شركات تصدير واستيراد القطن. وفي يعني ده بالنسبه لهذا الموضوع، وانا اعتقد ان ده موضوع يبقى موضوع مميز جدا وحاجه اضافه جديده لمركز البحوث الزراعيه في معهد بحوث القطن. وبالتالي ان شاء الله يعني نتمنى التوفيق، وان يكون بعد الافتتاح يبقى في حركه وفي تنشيط لهذا المركز، ويتم النشر عليه ويتم ارساله لجميع الجامعات وخاصه كليات الزراعه والمراكز البحثيه، حتى يمكن انجاز استخدام هذا المركز في رفع كفاءه نظام فرز القطن. نتمنى لكم التوفيق وشكرا ان شاء الله.
شكرا دكتور
النهارده دلوقتي
اوكي. هنعمل افتتاح دلوقتي، وبعد كده هنستكمل مع الدكتور كودر خبير الالماني بعد ما نخلص الافتتاح. دكتور
ممكن بايظ هنا في الشريط
one by one. مصر كده نبدا بسم الله الرحمن الرحيم. عندنا حضرتك اختصاصات الفرز الرئيسيه والتوصيف الفراغ اللي هو التوصيف النظري اللي هو ده بيقول بجول في الجول او كل جول او جول فين. بنستعين بالكتاب اللي هي النماذج القياسيه للرتب زائد وكم احنا
دواليب ولا دواليب اهليه؟
لا حضرتك بتبقى بوكس صغير بيبقى فيها عباره عن عينات من القطن كل وبالنسبه كمان الخيط بيتقدر كمان وصفي كجوده من ناحيه النظريه بتاعتها، وبعدين بعد كده نوصل للمعمل. اتفضل.
الاصناف
بين الاصناف في شوايب؟
لا يعني في انا عندي مثلا زي هيدا 86. ايوه بيقولوا في بعض صح؟ هل الجهاز ده سيميوليشن يبين الاصناف هنا وبالبعض؟
الى حد ما حضرتك يعني بمعنى ايه؟ طبعا هو الكونتامينيشن اللي هي بتفضل هنا بتبقى عباره عن الشوائب اللي بتبقى موجوده او المواد الغريبه اللي بتبقى موجوده في الأكل.
ايه هي الطيب
بتاع الشوائب؟ الطيب بتاع الشوائب بقى دي بتتفرز دي
ثلاث انواع مكون نباتي وفي مكونات
مين اللي جاي؟
الشوائب اللي موجوده حضرتك شوائب نباتيه بتنقسم لثلاث اجزاء: فلاش ما يسمى الفلاش اللي هو احجام كبيره منظوره، وبعدين فايبر فراجمنت اللي هو كسر التيله او التيله المتكسره اللي هي غير ناضجه، والمايكرو داست او الدست اللي هو عباره عن اتربه وكسر التيله اللي اقل من 500 ميكرون.
طيب يعني
دي نباتيه.
ده الميشن بيدي بقى الكواليتي بتاع
بالظبط الكواليتي بتاع
البرايس يعني
بالظبط بيساهم في طبعا صفات الغزل بيبقى فيها في صفات جوده وصفات خاصه بالرطب. فصفات الغاز طبعا صفات الجوده اللي هي المتانه والنعومه اللي هي الصفات الطبيعيه او الوراثيه اللي بتاثر عليه في المكان. اما بالنسبه للصفات اللي هو بيتكلم عنها الدكتور صفات الرطبه دي بتبقى معظمها صفات بيئيه وليست صفات وراثيه. عشان كده ما نقدرش نقول ان دي تستخدم في عمليه التفريغ بين الاصناف.
طيب لو انا ما يبقى ده ما بيبقاش
لا لكن بيحسن من خواص الغزل بعد كده عند الغزل مهمه جدا. صفات الرطبه بتبقى مهمه جدا وبتحدد بيها اسعار القطن. يعني اسعار القطن اساسا عالميا بتتحدد عن طريق الرتبه، وكان في مصر بتتحدد برضه عن طريق الرتبه الى عهد قريب يعني. وده اللي احنا بنطالب بيه، ان بعد كده اسعار القطن لازم تحدد طبقا للرتبه بتاعتها عشان نحصل على قطن ليه جوده عاليه. يعني قطن البيمه الامريكي
معلوماتي اللوج اكسترا غير الشغل سعره مختلف. صح كمان؟
ده في جوده.
فبيبقى فوق الطول ده سعره بيختلف عن
بس داخل نفس الطبقه، داخل نفس
لازم
الطبقه
السعر كمان يختلف
يعني
طبقا
داخل
للجوده طبعا.
داخل بيبقى جواها
يعني مثلا في نفس الصنف نفسه اذا كان جيزه 86 او 89
لازم السعر يتفاوت.
يتفاوت بقى طبقا لايه؟ لدرجه
نفس
النظافه والمواد الغريبه والشوائب اللي بتبقى فيه، لانها بتاثر جدا على صفات الغاز. حتى لو كانت صفات الجوده بتاعته عاليه، ولكن لو رتبته منخفضه بتتاثر صفات الغاز.
ما بتبانش صفات الجوده عاليه.
فهو اتفضل.
دي جزئيه الشباب حضرتك خلاص، ان هو جزئيه اللون اذا كان اللون ابيض او كريمي توصيف اللون، ان هو توصيف النعومه والنضج.
لا بس مش القطن ده في الصناعات، يعني القطن طبي ايه ابيض ثلجي.
ده اللي من
صح، ده طبيعي.
عمال عليه طبيعي.
في القطن العادي كده بيبقى واخد اللون الكريمي الطبيعي، يعني ده اعتقد ده الناتشرال صح؟
اختلافات صنفيه طبعا.
وبعدين القطن الطبي بالمناسبه بيبقى ارضى انواع، بيبقى بالشعرات قصيره جدا بيتعمل منه، بيتعمل له تبييض وبتاع بيستخدم منه.
بعد كده صفات النعومه والنضج مع بيبقى صفات جوده مره واحده. صفات الجوده كلها خاصه بالمكن الجوده، يعني لما الشعر بيخش على المكن الصفات دي مطلوبه ومهمه جدا جدا للغسال. والتصنيف اللون
يعني الجهاز يستطيع ان يصنف بين اقطان المختلفه. الجريد يعني هقول لحضرتك، يعني مثلا انا افترض دلوقتي عندي جيل 86 رتبه عاليه، جيل 86 رتبه منخفضه، يستطيع الجهاز
او رتبه وسطيه
يستطيع الجهاز ان هو يميز من خلال وحده الطول والسترينث ومن خلال وحده النطق.
هو مش في ستاندرد للطول بتاع اللون اللي هو 32 صح كده ولا لا؟ مظبوط. هو برضه يقدر
كل الكلام ده بالتفاصيل.
وهنا حضرتك بقى المهام او الميزه بقى في المركز التميز ده انه بيربط ما بين صفات الجوده وصفات الرتبه مع بعضهم، بحيث ان هو بيطلع صفات
الرتبه نفسها متوصفه
وصفات الجوده
بتاعتها
اللي هي متعلقه بيها او مرتبطه بيها.
والفند احنا خدناه عشان الجزئيه دي، ان الرتبه نفسها سواء فولي جود او جود فولي جود او فولي جود فير او جود اوروبا، جوه الصنف نفسه مواصفاتها التصنيعيه ايه ومواصفاتها التسويقيه ايه.
طبعا يعني
هنا طبعا دي اجهزه حديثه
دي اف طبعا، يعني على اساس ان هو في منح كثير من المشروعات بيبقى ليها طبعا وضع ابلايت كثيرا وكده طبعا. والقطن يعني انت عارف ربنا سائل كده، يعني في وزاره واخده بعض الاجراءات ان شاء الله القطن يرجع لوضعه الطبيعي ان شاء الله باذن الله. والله وحضرتك انا يعني ايه، انا بقول ان التطبيق لازم يبقى متوازي. ازاي؟ لو انا المفروض ان ابقى في تطبيق عندي مشاكل عندي في مصانع الغسالة حضرتك، فهو لازم يبقى بدل انا بطور المفروض ان انا عندي الناس اللي هم اقسام محافظه على الاصناف والكلام ده بيطلعوا بعض الاصناف اللي هي الفائقه، والمفروض يبقى في مشيه متوازيه مع مصانع الغسالة. احنا مشكلتنا ان احنا بنطلع من بس ما بنعرفش نصنع. مشاكل كثيره مش في الزراعه بس عموما، يعني احنا بنوصل الحاجه اللي بترجع لنا تاني. يعني مثلا معروف سافر اوروبا او سافر الكلام ده معروف فانا اعتقد ده يدي اضافه خلاص. يعني يدي اضافه.
ده هيبقى في تعامل مع جهات خارجيه هتيجي تقدر برضه العينات اللي معاها، سواء شركات صناعه او شركات تجاره، هتيجي تقدر عيناتها وتعرف العينه اللي معاها دي تنفع تنزل اي نوع من انواع البذور، اي نوع من انواع الملابس، هل الجنس، هل الحاجات اللي فيها.
احنا جايين النهارده انا قلت للدكتور كلام مركز في عدم تواصل ما بين البحث وما بين الصناعه.
يعني بعد
عندنا كونتامينيشن
بقالنا شهر. ايوه انا عارف
الكونتامينيشن دي حلول من اول التحليل صناعه.
ما هو انت عاوز تعرف احنا بنغير في القانون، خلي بالك عاملين مذكره للوزير بعتها دلوقتي
زي الاول
طلع اقتصاد بره التسويق حر فيما عدا فانت تقدر تحافظ. يمكن احنا عملنا السنه دي محاوله على اساس ان احنا تعاقد اللي احنا عملناه على اساس ان احنا نبتدي نحافظ، زائد ان طبعا الفوازير والكبادين والدواليب الاهليه فبالتالي دي مشكله خلاص. وبعدين المشكله ان هي التسويق الحر، ان هو المشاكل اللي ادت لذلك ان كلمه علاوه الاقتصار، فكل واحد كان بيلم بالك مع الدواليب الاهليه ده احد الاسباب برضه اللي هي ادت لحدوث الكونتامينيشن. فانا اعتقد ان الجزئيه اللي احنا اتكلمنا السنه دي هتحل مشكله الاصناف، هتبقى الاصناف ويمكن احنا عندنا الوزاره خلاص قطاع زي قطاع الانتاج زي ما هو بيعمل دلوقتي. اعتقد اسرائيل زي قطاع الانتاج مثلا هنا في 13 فدان اللي هو الصنف الامريكاني خلاص، فده معمول عليه خدنا فلوس من مجلس القطن عشان نشتريهم. ايضا بعض الاصناف عشان طبعا يعني كان اعتقد في 86 كان بيوزع خلاص، فاحنا لحقنا ودينا له اسطوانه اكسجين تنفس صناعي. فاعتقد ان قطاع الانتاج دلوقتي بيشتري هذا الموضوع ودي لمحلب واحد على اساس انك
بيشتري اللي هو الاكسار.
المشكله اللي حصلت بالذات 3 4 سنين اللي فاتوا، اعتقد انتم عارفين السنه اللي فاتت حصل في اسيوط برضه. فدي طبعا هي يعني للاسف التاجر بيدور على المكسب، فبيلعب هذه القصه واخد بالك، بس ده بيؤدي لمشكله خارجيه والسمعه بتاعت. فانا اعتقد وجود هذا الجهاز ده بيبقى اضافه ان احنا شغالين في الاطار السليم الصحيح، ان احنا بندور على كواليتي، وان شاء الله القطن يرجع يعني لو بالتوفيق ان شاء الله.
الله يخليك يا فندم.
احب طبعا ارحب بضيوفنا من صندوق علوم التكنولوجيا التنميه التكنولوجيه، وتحياتي للدكتور عمرو يعني اتمنى ان انا اقدمه يعني. نشكركم ونتمنى مزيد من الدعم والتعاون ان شاء الله في المستقبل القريب لصالح القطن المصري طبعا. Now, it's a pleasure for me to welcome to Dr. Kobler, the German expert, and I'm very grateful for you, scientific attendance, our sermon, our opening sermon. And now Dr. Kobler will present my presentation to expose or demonstrate
here at the Cotton Research Campus. Again, congratulations. I am really glad, and this is a good opportunity, because a good opportunity for finding new ways of the classification of Egyptian cotton, and I'm very proud that we could do our part, that in future the Institute will have new opportunities for research. Second point, allow me to take off this, I need more freedom when I speak. So now I feel much better. So, thank you for coming. We have now seen in the laboratory already the cotton classifying system CCS version 5, and I would like to give a short presentation about the features of this instrument system. But before, let me introduce our company. Textile testing technology made in Germany by Textechno Stein GmbH. Our company is located in Mönchengladbach. This is not far away from Cologne, not far away from Düsseldorf. And Mönchengladbach, this is in Germany, the city of the textile machinery producers. In Mönchengladbach you can find Trüschler, you can find Schlafforst, Montfort, and also Tech Special. So this is our company building, and we are proud to have these companies in Mönchengladbach like Rüttler and Lefrz as our customers. They are using our testing instruments. Let me give you a short history. Our company has been founded just after World War II in 1949 by Mr. Engineer Herbert Stein. At first it was a consulting center only for the textile industry, but Herbert Stein found out very soon and very quick there are no testing devices on the market available. So how we can test the quality? And he started later on to produce own developed testing devices. Within the last 60 years, Tech Special became, together with our daughter company Lansing Instruments, to the #1 in man-made fiber and filament yarn testing. In 1994-1995, our company decided also to produce testing devices for the cotton field. At that time, man-made fiber companies and also filament yarn companies were suffering, and we had to decide how to continue. So we decided to go into the cotton field. But only in 2007, on the ITMA in Munich, we opened a complete new product line, what we call Tech Special Cotton Control line. And our cotton classifying system, CCS version 5, belongs to this cotton control line of Tech Special. So, but now let's start with the technical things. Cotton classifying system version 5. The system has been developed for classification and also for spinning mills in order to assess the spinnability. So this is a different way, like Uster or others, Premiers, Startex, they went. They have developed the high volume testing instruments, especially for the classification of cotton. Our target was it to develop a system of instruments what is able to fulfill both tasks, to classify cotton and to be able to measure also the spinnability. The difference is as follows. When you are going to classify cotton, you need to measure in comparison to calibration cotton. But if you would like to measure the spinnability, you have to measure all parameters absolutely, directly, without using calibration cotton. With our system, we are measuring micronair value, maturity, fiber count, length distribution, strength, elongation, whiteness, yellowness, naps, trash, seafood naps, on all short stable fibers absolutely. That means no calibration cotton is needed. But you can also measure, especially cotton, in relation to calibration cotton. The system is very flexible in terms of testing parameters and measures raw fibers from the bales, and we can also measure sliders. We call this system a medium volume instrument because we can measure practically 20 samples per hour, and we can duplicate the classification results by using calibration cotton. So we believe that our system is a really alternative system to high volume instruments. So this is now the system what we have seen here in the Cotton Research Center. And I would like to explain a little bit more. The cotton classifying system is a modular system. It consists of several stations, as you have seen, and all these stations are linked, connected with a central computer, on which runs a database what collects all the measured data from the individual stations. It has been especially designed for cotton testing, but during the development we found out that we can measure all types of short stable fibers. That means viscose fibers, tensile, polyester fibers. This is possible because for the polyester, viscose or tensile fibers, we do not need calibration fibers. We can measure all parameters directly. The cotton classifying system consists of 5 stations: micronair station, fiber column station, fiber test station, the central computer station, and net and thresh station. Let me explain now every station a little bit more in detail. I would like to start with the most important station in this cotton classifying system, because this is really a unique testing instrument. What is the only one what can measure strength and elongation absolutely. That means no other HVI can do this, only fiber test. As I already explained, this is a testing instrument what can run in the system. It can also run separately. This is a sweet label instrument for the spinner, for ginning mills, and also for research centers. In case of application for the spinners, it is possible to test the incoming cotton in order to check the HDI data, and we can test the spinnability. On the left side here, you can see the testing device itself, and inside the picture on the lower side, right lower side, you can see the clamp with a fiber bundle, and this red line, this is also a new development. We are using for the elimination a laser beam. And below this laser beam we have a CCD line camera in order to measure the length distribution. On the right side you have the sample preparation unit. I would like to show how all these parts of the instruments are working together. First of all, the sample preparation. So this is a flat carding sampler. You prepare the sample and put it into the chamber. Close the flap, and then we switch on the compressed air, and the compressed air presses the fiber material against the perforated plate, so that you can realize that the fibers are looking through the holes always on the same manner, in the same height. So then we draw the comb over the flat carding sampler, and we remove naps, and at the same time we parallelize the fibers. After that we insert the clamp into the tester. So you can see this red laser line already here, but in the next picture you can see it better. So now we scan the fiber length. So now you can see this red laser line very good. After we measured the length distribution, we move to position for the strength test. The drawing clamp is closed, then the fixed clamp is closed, and then we break the fiber material, and then comes the job what the tester is doing, what is completely new and what is unique. We cut out the broken fiber parts between the clamps and move it automatically onto the balance. That means we have measured before the force, braking force in Newton. We now measure the weight of the sample between the clamps, and because of the gauge length between the clamps, we can calculate the fiber bundle count in tens. So we have the force, and we have text, and then we can easily calculate from the text the strength. So during the test, you can see these diagrams and graphs on the computer monitor. On the left upper side, you have all fibrograms in one picture. On the left below side, you have all strength elongation curves in one picture. Right upper side is for one test what is shown for the length distribution. We see the yellow line, this is a fibrogram. We see the red line, this is a stable length curve. And we see the histogram, that means the fiber length distribution in all length classes. And what is also new, what you can see below, due to our very flexible optical system for the measurement of the length distribution, we can see the picture of the sample. So these are the measured data during the test. You see here, and it shows, okay. Yeah. I have also to find a video. So anyway, when you have a look to the individual test data, you can see here on the left side upper half mean length. Then you can see approximately in the center SFI, short fiber index, then UI, uniformity index, and then maximum force, elongation, and strength. So these are the data what you are usually getting from the HBI. But we have some additional data. For example, upper quartile mean length on the second position. This you can get only from the AFIS. Or mean length, short fiber content. These are also parameters what you are getting normally only from the AFIS. And we have 50% span length, 25% span length, 2.5% span length, uniformity ratio, and mean length. So these are the parameters what you can get usually from an HDI, what is calibrated with international calibration pattern. In our case, you are getting all this data with one test. For this development, for this testing device, we have got a recognition from the International Textile Machinery Federation. There is a working group, International Committee on Cotton Testing Methods, ICCTM. I belong to this group since around 16 years, and for this testing device we have got a recognition, what means this is a recommended testing device for research, classification, and spinning mills. Now let's come to the second station, micronear station. You can see the testing device and you can see a part of the software. And we measure with this CCS micronear station the micronear and maturity. It is equipped with RS-232 interface and touchscreen display. The measured data that we are measuring here are micronear value, maturity value, percentage of mature fibers, and the linear density in millitex. Can be used for cotton, polyester, and viscose fibers as well. This is a fiber color station, what measures the whiteness and the yellowness. It is a real spectrophotometer with an Ulbricht's-Vary. It has an integrated microprocessor. The connection to the central computer station is made via RS-232C interface. The calibration normal and the software belongs to the scope of supply. We measure the whiteness, RD, and the yellowness, plus D. For the measurement of the naps, trash, and seed coat naps, we have two different solutions. One solution, what we have seen here in the laboratory, is the so-called naps and trash station. We measure naps, seed coat naps, and trash. The analysis of naps, trash, and seed coat naps is done via computer. On the computers there is a high-resolution scanner, and by using image processing software, we count the trash parts, seed coat naps, and naps part per 10 gram, and measure for 10 gram, and calculate down to 1 gram, like Mr. Apples is doing. So it can be used for raw cotton and slivers. Usually we are using a mass of around 10 up to 50 gram, what is a statistically secured mass according to our experience. The second version what we can offer is the MPTA3 and NTA module. This is a more sophisticated testing device, and it forms during the measurement, like you can see here on the left side, a sliver, a ring of sliver, and this testing device can be used for more applications, not only naps and trash testing. For example, it can be used for the measurement of the stickiness as well. Stickiness plays in the last years a very big role, especially here in Africa. The cotton from Chad has such stickiness problems, and also Sudan cotton has such problems. Anyway, the next application for this testing device is the measurement, or better to say, the mixing in case of production of melange. So you can see when you blend the black polyester fibers with the white cotton fibers, how is the mixing, what color you are getting out. You can control all this by using the MPTA3. The central computer station has a database software what allows a lot of different functions. One function, for example, is data management. Another function is, of course, the measurement itself. We have also, for many customers, a very interesting lot mixing function, what can be used in order to find an optimized blending between different cottons with different parameters, or also for blended yarn producers. You can pre-calculate what you have to expect, what parameters you have to expect when you would like to measure this, both cotton 1 and cotton 2, or cotton and polyester. You can set different percentages, and the computer calculates you what parameters will come out when you blend these two things together. So another integrated function is that you can compare directly the measured values with USDA quality recommendations. So you can see here on the left, quality elongation, very high tenacity, medium. So this is calculated also automatically on base of the USDA quality criteria. So now I have presented the system. Now, of course, comes the first question. The most important station, as I already told you, is the fiber test station. It measures the length distribution, strength, and elongation, and is the equivalent to the length strength module of HDI testing devices. So the question is now, the results what you can get from CCS fiber test, we call it shortly FDF. Are these results comparable with the results of the HDI length strength modules, or with the classic testing devices like fibergraph, micronair tester, and so on? So this we can only find out with comparison tests, and this we did. The first is this research for the results, what I can show you here, has been done with the Texas Tech Institute at the university in Lubbock, Texas. So we tested on an HBI, what this institute has available, 12 different cotton samples from Texas on this HBI and on fiber test. The results you can see here for upper half mean, length, uniformity index, strength and short fiber index. And when you compare all these testing results with each other, you can see that you have for all parameters a quite high correlation. For example, for the upper half mean length, 0.982 correlation, what is nearly 1. For the uniformity index, 0.955. Even for the strength, 0.950. Only for the short fiber index, it is a little bit lower, 0.859. The next page shows when we compare the results with classic cotton testing devices, for example, Kaisoki classifier or stelometer. We measured here not on stelometer, we measured on our photograph, but we are using stelometer clamps, and we cut out the bundle between the clamps and we were weighing this, and also here you can see a quite high correlation. For example, 2.5% span length between classifier and fiber test correlation 0.812. For the 50% span length 0.906, and for the bundle strength also 0.964. So that means the fiber test can be compared, the fiber test results with HBI test results, but can also be at the same time compared with classic testing devices like classifier, fibrographs, and stelometer. So already during the development of the testing device, we have seen there is something wrong with the strength test. But we have not known, is the strength test problem on our side, or is it on HBI's side? As I already told you, we are able to measure the mass of the fiber bundle between the clamps. What gives us the possibility to calculate the measured strength absolutely. So, and now we did following. We tested 10 cotton fiber samples on fiber test, absolute measure, on an HBI 900, calibrated with international calibration button, on an HBI 1000, calibrated with HBI calibration button, on the photograph, tensile test on single fibers. We measured 300 fibers. That was horrible for the lady what made these tests. And we measured on photograph with stelometer clamps and manual weighing of the sample mass after the test. The results what we have got out are really very surprising. So you can see in the first column, fiber test absolute measured data. So we are getting out an average value of 17.19, and photograph fiber bundle test, according to the stelometer method, we have got out 18.41. When we take in consideration the statistical variation of the samples what you are going to prepare, we can say, okay, fiber test, absolute test is very, very equal to stelometer results. Then we have the HBI 900 calibrated with international calibration button. You can see 23.25, what is something in between, And then you have the HDI 1000 calibrated with HDI calibration pattern and single fiber test results. And look, this is the biggest surprise. The single fiber test results and the HDI 1000 results has the same strength. What is from the physical point of view impossible. It is really impossible. Because it would mean that the test on fiber bundle in case of HDI would mean that the bundle strength is equal to the number of fibers in the bundle multiplied with a single fiber strength. That would mean that within the bundle all fibers would break at the same time point, at the same elongation, what is in practice never the case. So this you can see here. So this is these both tests. On the left side, you can see force elongation diagram for single fiber tests on ESA 90 LS. And you see that the fibers do not break at the same time point. They break at different elongations. And on the right side, you can see the bundle strength and the results. Look, we measured for the strength on Fatty graph for single fiber test 33.46 gram per dex. For the fiber test, we measured in absolute mode only 20.04 and the HDI measures 34.82. This is impossible. What does it mean? It means the HDI measures the strength complete wrong. But this is not related to the HDI itself. It is related to the standard values for the strength and elongation, what is given from USDA for the calibration pattern. And HDI cannot measure without calibration pattern. Yeah? In a second step, we can say, the strength values, what you are getting from the HDI, are okay for the classification. Classification means that the relation between the different varieties are in the same range. But such results are very, very dangerous for the spinner. Can you imagine? The spinner believes he has a very strong fiber material available. And when he has seen the results, he is going to decide, I can process this strong fibers with a very high speed. And then when he processes his fiber with a very high speed, he is wondering when he is getting yarns with a high CD value and a lot of imperfections. And the other thing is, the yarns do not have the expected yarn strength, which is calculated on base of the measured HDI fiber bundle strength. Now we made a second step, and we had a closer look to the elongation. So the question appeared, how are the elongation values of the HDI 1000 and the fiber test in relation to each other? To find out this, we tested 8 different cotton samples from Texas. The samples have been tested continuously over 5 days, what means we have totally tested, we have made 40 tests. The test has been performed either together with the Texas Tech University in Labo and for the fiber test in our laboratories. The results you can see here. You see upper half mean length, excellent correlation. Uniformity index, very good correlation. Short fiber index, strength, but look to the elongation. Look to the elongation. Between HBI and fiber test, we have only a correlation of 0.49, what is in fact no correlation. Yeah? So, and then we made following. And this is surprising. This year, during Bremen Cotton Conference, 3 institutes and companies came independent on each other to the result that also the elongation measurement at HBI is wrong. So here on the right side, you can see a picture also from Texas Tech University. They made, by using our FAFI-mark, a lot of single fiber tests. And you can see there is, I would not say a correlation, but I would say a strong tendency between strength and correlation. The same we have seen on hand of these 8 samples for which we made 40 tests. You can see the blue colored dots are the test results from the HBI. And you can see for all strength values, starting from 26 grams per tex up to 35 grams per tex, we have the same elongation. How can be? How can be? Also impossible. So the pink colored dots came from the test of the fiber test. Here you have the same tendency like for the single fibers, that strength and elongation do have a tendency that with a higher strength, also the elongation is getting higher. So, because of this, we had a hard discussion during the Cotton Conference in Bremen in March this year. And within the ITMF meeting of the International Committee on Cotton Testing, we have asked USTR how they are measuring the elongation. And a very crazy thing came out. Because of the fact that they do not know the count of the fiber bundle, they have no starting point like we have. In our case, you can see our elongation measurement starts always from the same point because we have a clear definition. We start the calculation of the elongation at a pretension of 5 cm per tex. In that case, this tex is the count of the fiber bundle. So in case of Buster, for every single fiber bundle strength curve, they have another starting point for the elongation. How you can see here. So they are using a tangent on the hook area, and they start the elongation measurement when this tangent crosses the elongation axis. So I tried to make a picture, I hope it is to understand. So for example, for the upper curve, what has a higher strength, and for the lower curve, what has a lower strength, the breaking point is nearly the same. So we would expect that we have also the same elongation. But this is in case of HBI not the case. Because the tangent of the higher curve, what has a higher angle, ends here, and for the other curve, ends more to the left. So that means the first curve with a smaller strength has a higher elongation than the bigger strength but has a shorter elongation. Absolutely unlogical. So the last one I would like to show is, this is a measurement done with Egyptian cotton, the relation between elongation and strength measurement, and also here you can see there is a clear tendency, higher strength, higher elongation. Thank you for your attention. Yes, yes. So this is what I told during the explanation. The system of this new quantum classifying system is that it can replace HDR lines. But at the same time, it can be used in order to measure the spinability. And for the spinability, I tell it again, we have to test the real strengths, we have to test the real lengths, and not the strengths and lengths in calibration to HDI calibration pattern. Yeah? Yeah? Ah. Hello, nice to meet you again.
You mentioned something about measuring the fiber elongation. Do you believe that the instruments we use for measuring fiber elongation are accurate enough to depend on its depth?
I do not believe I measurement, and this cannot be correct.
From our research work, we believe that measuring fiber elongation is not accurate because of the character itself, and the distance between the jewels is very, very small to be measured. This is my first.
Yes, but why we are able to do it?
Yeah. The second one is about measuring strength. When we measure strength by HDI, we get the resultant of the single fiber strength, as you illustrated. But you mentioned also that we use the HDI for classifying the different loads throughout the different samples according to its strength, which could be used also in the spinning rig. So,
yeah, the problem is, look, I agree when we speak about classification. I agree when we speak about classification, but the problem is the Egyptian cotton is much more stronger than all the other.
It is a certain question there. Because here we have a specific level of strength. When you mention Giza 90 and the short stable outline, we are dealing with a very low level of strength. But here in Egypt, we have something about 50 gram text in strength, which when we deal with the data of the extra long stable strength, I think the conclusion could be different or could be modified. Thank you, sir.
I mean, we measured this cotton. Maybe I can show you some results. So, Cotton Institute Giza. So, for example, Giza 92, 50 gram per dex, absolute strength 30. So this is in relation to calibration cotton, this is absolutely measured. So also here 45, 46, 26 and 27. So you see, in fact, the direct measured strength, when you take the double value, approximately, then you come to the HBI strength. And this, I'm sorry, I cannot understand. So there's nothing to do with physics, and I'm an educated physicist. Yeah? Also for the, we made also some tests with, let me check. I have some more data. Here. So we have measured, for example, with the Fatima single fiber tests. And you see here tenacity 35. And the same we have tested with, this is 85, no, it is in comparison to calibration quadrant 46 and the real tenacity 25. So the problem, according to my opinion, is as follows. All the calibration quadrant, what you can get. We have short weak and long strong. And mostly the long strong are in strength or not higher than around 35, maximum 40. But look, your cotton is much more behind this. And surely you can measure only what is on the calibration line between these points. Who knows? Who knows how the calibration line, is it like this or this? Nobody knows.
We are preparing our calibration on now the high strength ejection.
This is a good idea. And for this purpose you can use our fiber test.
Thank you, sir.
Dr. Munier, it is always a pleasure to have a discussion. Already in the past we had always very technical, detailed discussions. I miss you so. Yeah.
I would like to thank you for this abundant lecture. I hope that I can take a print or summary of recent research work. If you please give your thoughts. Yeah. Thank you.
Yeah.
Another question.
So anyway, it was nice to be here. I thank you again for your attention. And look, we are always everywhere. It's very good. Oh, one more question.
Thank you for this presentation. I see that you can measure not only the cotton but also man-made fibers.
Yes.
Is it possible to measure the length of cotton polyester? And is it possible to determine the percentage of length?
The percentage of polyester and
Yes.
No, this is with this tester not possible.
Not possible.
Yeah, there are testers on the market that can be used in order to measure the percentage, how many percent cotton or how many
We
percent
need a
polyester.
sensitivity. We need a sensitivity in our labs.
Yeah.
But it's not easy to measure it by this system.
Yeah.
Not easy. Thank you.
Maybe the next step.
I hope